Hello, I am Jean-François Denise from the WildFly team. Today I am going to demonstrate how WildFly Glow handle connection to your database when deploying your application to OpenShift. But prior to start, I would like to share that we have released WildFly Glow 1.0 final. You can download it from the URL on the top of my head. In this release, we have added interesting new features, such as the one I am going to demonstrate. So new features in particular in the scope of OpenShift. So before I start the demo, I advise you, if you didn't look at it already, to have a look at the previous video I made on WildFly Glow that explain how to set up your OpenShift cluster and connect to it. It's very simple. It's few steps, but I will not redo them in this demonstration. So let's first look at our OpenShift console. We can see that we have no resources. The cluster is empty. And let me switch to the terminal. So I have downloaded the latest WildFly Glow release, and I am going to scan the to-do backend example application that is packaged with WildFly Glow installation. So that is a quick start, a WildFly quick start that requires the database to persist the list of tasks this to-do backend application is handling. So let's first start by scanning this application. So WildFly Glow has discovered the latest WildFly released. WildFly 32 final has just been released, and a list of layers. Interestingly, we can see that we have an unbound data source error. So there is a data source that is referenced from our WAR application that has no connection, has no support for database, and WildFly Glow identified it. So it is suggesting us to select one of the following add-on. So an add-on is an extension that we are going to include inside the server we are provisioning in order for our application to properly connect to the database. So we can see that we have a list of 5 add-ons that are suggested, and 3 of them have a supported OpenShift deployer. When an add-on has an OpenShift deployer, it means that it is going to WildFly Glow is going to automatically deploy the database server and connect the application to the database. So this is what we are going to do. We are adding the PostgreSQL add-on and provision to OpenShift. So let's look at WildFly Glow output. I am going to go up a bit. So we can see that 32 final has been discovered. The cloud feature pack is used because we are deploying on the cloud. And the data source feature pack is also included because this is the feature pack that brings this PostgreSQL add-on. We can see the list of enabled add-ons. We have the ELF add-on that has been enabled. This ELF support is needed in an OpenShift context because your application is monitored by the OpenShift probes for its states, is your application is properly running, etc. So there is this ELF add-on that is enabled. We have the PostgreSQL add-on that we have explicitly added, and the WildFly CLI add-on contains all the toolings, all the command lines that comes with WildFly. They are required internally when deploying to OpenShift, because when the server starts, some adjustments are done using the WildFly CLI. So we can see that we have our problem that has been fixed by using the Postgres SQL add-on. But you need to set strongly suggested configuration. So we have a set of environment variables to set when using this add-on. But as we are going to see, because the deployer OpenShift PostgreSQL has been enabled, actually it is handling for us all the configuration aspect. So it seems that the resolver has resolved all the environment variable. So we are going to trust Glow there. And let's look at the output. So OpenShift build and deploy has started. It is connected to the OpenShift cluster. It has found the PostgreSQL deployer for the PostgreSQL data source layer. It deploys the PostgreSQL server and advertise a list of environment variables that have been set in the deployment. That is interesting in case you want to replicate outside of Glow this kind of configuration. You would need to set the following environment variables, such as the password, the username, the host and port. Then the server image is started, and the application image build is started. So let me give you why we are doing two builds. The first build is building the image, an image that only contains WildFly server, no deployment. This image can be shared when building the actual application image. That's an optimization. This allows us not to provision and rebuild everything each time in case you have applications that share the exact same server. So then we have a second build that is simply copying the deployment into the server and creating an image that really contains only the server and your application. And it seems that it has been quite fast because the application is already ready and the route to your application is advertised there. So let's look at our OpenShift console. So let's refresh it. So we can see that we have the PostgreSQL server that has been started and our to-do backend application. So we can have a look to the logs. Let's switch to the administrator view, workloads, deployments, to-do backend, pods. I am selecting one of these pods and I would like to have a look to the logs. It can take a bit of time, some time for the console to refresh. So let's look at the raw log. And I would like to make sure that everything went well. It seems that we have WildFly 32 that is up and running with my to-do backend war deployed, no error. So now what we can do is to have a look to, we are going to access the application. So here we have, let me switch to the terminal. I can curl this root and we can see that the list of to-do is empty. So I will stop there the demonstration. So we learned that using WildFly Glow, you can deploy your application. If it requires database, it will detect it, suggest you with some add-ons, and if you deploy to OpenShift, it will automatically connect your application to the database. Thank you very much and see you in a future video. Goodbye.